Now that your definite integral skills are hopefully growing and you're feeling more confident about them, we do have to also look at solving definite integrals that are a little more complicated than the ones that we've done so far. If you think about the definite integrals that we've solved, they've all involved addition or subtraction. The ones that involved division were very quick natural logs, or we were able to simplify them so that there no longer was division. The ones that involved multiplication, we may have had to FOIL or pull out a coefficient, but there wasn't anything that was really difficult in that regard. In essence, we had no composite functions. We had no inner functions. And what we need to be aware of, though, is that those functions are out there, and we have to be ready to anti-derive them and solve them. And so what we're going to do is we're going to use our skills from the previous lesson, which is when we did U substitution. We're going to take that topic, and we're going to take the skills that we just learned with the definite integrals, and we're going to merge them both together. And now we have this new idea where we're doing definite integrals with U substitution. All right, so we got shorthand this definite integrals with U substitution. All right, we're merging it together. All right, it's like those commercials where you have the peanut butter and the chocolate and they merge together to make the Reese's peanut butter cup. That's what we're doing right here. May not taste as well, but it's still a lot of fun. All right, so here we go. What's the idea? We're going to take our extensive definite integrals that involve x, and we're going to turn them into easier definite integrals, ones that we can anti-derive rather quickly. They're going to involve u. We're going to do the u substitution part there. Take something that's hard and turn it into something that's easier to anti-derive. Okay. Now when we change over from x to u, it's very important that we change everything over from x to u. All right, so not only are we going to change the integrand. Okay, so remember the integrand is when we say u is equal to whatever. Okay, we have to change that from x terminology over to u terminology. Okay, same time, we also have to change over the differential. All right, remember u does not want to be involved unless du is involved as well. So those two parts aren't really all that new. U and du making those substitutions. We get rid of all the x terms, and we just have u terms involved. So u and du, those are the first two things. What we got to be careful now is what we've introduced with definite integrals as we have bounds. Now those bounds are the numbers at the lower and upper end of the s. Okay, those bounds initially are in terms of x. We need to change them over into terms of u, because again, we don't want any crisscross between the variables. If we're changing over from x to u, then the bounds need to be in terms of u as well. Okay, so that's our third, our bounds, our a and our b. That's an a right there. Okay, now to convert those bounds is actually rather easy. We're going to use the connection between u and x that we identified, because u equals blah, 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 involving x. Well, that is our formula for converting from u or from x over to u. So we can use this equation that we're going to come up with, as you'll see in the examples, and we'll quickly change our bounds. But it's quite important that you do change your bounds, because if you're using x as bounds on a u situation, it's going to produce the incorrect answer.